The shadow of the Silbervogel stretched far into the height of the Cold War, directly shaping the crowning achievements of the space age. In the late 1950s and 1960s, as the United States and the Soviet Union transitioned from ballistic missiles to human spaceflight, the flat-bottomed, wing-lift design pioneered by Eugen Sänger and Irene Bredt re-emerged as the blueprint for the future. The concept of a winged vehicle that could fly into orbit like a rocket, ride the atmosphere, and land on a conventional runway like an airplane became the holy grail of aerospace engineering. The United States military was the first to openly resurrect the spirit of the Silver Bird with the X-20 Dinosaur dynamic soaring program. Orchestrated by the U.S. Air Force, this experimental program sought to build a piloted sub-orbital military spaceplane that utilized the exact hypersonic skip-glide principles mapped out in the Trowan laboratories. While the Dinosaur was eventually canceled due to shifting funding priorities and the immediate needs of the Apollo moon missions, the treasure trove of hypersonic aerodynamic data it gathered laid the direct technical foundation for a much grander endeavor. When NASA unveiled the Space Shuttle program in the 1970s, the physical lineage of the Silbervogel became undeniable. By replacing Sänger's flawed assumption of a metal-cooled skin with advanced silica tiles capable of insulating against the intense thermal shockwaves, engineers finally solved the riddle that had doomed the Nazi project. The shuttle's iconic delta wings, its flat underbelly designed to ride atmospheric shockwaves, and its reliance on a thermal protection system to survive the white-hot furnace of re-entry were all modern, successful executions of the problem Sänger had tried to solve decades earlier. Decades later, the Soviet Union mirrored this exact lineage with its own automated spaceplane, the Buran.
Ultimately, the Silbervogel achieved immortality not as a weapon of terrifying destruction, but as a conceptual bridge between aviation and space exploration. The machine itself never tasted the thin air of the upper atmosphere, and its original purpose was born of a brutal, tyrannical ambition. Yet, the revolutionary architecture drafted by two visionaries survived the collapse of empires and the shifting tides of history, proving that while the political regimes that fund science are fleeting, the raw physics of the cosmos endure.